Realme 9i 5G camera test. Peace be upon you, my dear friends and followers of the channel. How are you today? I hope you are well and in good health. Today with you is a beautiful, new and important video for everyone. This video will be called the Realme 9i 5G camera test. But before watching the video, subscribe to the channel and like and share so that it reaches the largest number of people. Now let's watch the video and I hope you like it. We put the Realme 9i 5G through Xmark's stringent camera test suite to measure its performance in photo and video quality and zoom from an end-user perspective. In this video I will explain the device's performance in a variety of tests and several common use cases and aim to highlight the most important results of our testing through a snippet of the data captured. Overview. Main camera specifications. Primary, 50mm lens, f/1.8 aperture, daf. OIS. Pros: good exposure for photos and videos in outdoor conditions, accurate focus most of the time in photos and video, good balance between texture and noise in outdoor conditions. Cons: repeated visual exposure, instability in photos and videos, sometimes inaccurate color rendering in photos and videos, inaccuracy and instability in portrait mode, limited overall capabilities for indoor and low light video. The Realme 9i 5G delivers good camera performance when shooting conditions are good for stills and videos. The device is suitable for occasional outdoor photography or video, but photo options will be limited as the device lacks good zoom and an ultra-wide unit. When shooting in more challenging lighting conditions such as indoors or low light, the resulting images will have a significantly reduced level of detail. About Xmark camera tests. Xmark camera evaluations are conducted in laboratories and in real-world situations using a variety of subjects. The results are based on objective tests, in which results are calculated directly by measurement software on our laboratory setup, and on perceptual tests, in which a sophisticated set of metrics allows a group of image experts to compare aspects of image quality that require human judgment. The smartphone testing involves a team of engineers and technicians for about a week. Image, zoom and video quality are scored separately and then combined into an overall score for comparison between cameras in different devices. For more information about the Xmark camera protocol for recording and analysis, Xmark engineers capture and evaluate more than 2,600 test images in controlled laboratory environments and in outdoor, indoor and low-light landscape scenes, using default camera settings. The photo protocol is designed to keep key use cases in mind and is based on typical photography scenarios, such as portraits, family portraits and landscapes. Evaluation is performed by visually examining images against a reference of natural scenes, and by performing objective measurements on chart images taken in the laboratory under varying lighting conditions from 1 to 1000 plus lux and color temperatures from 2300 K to 6500 K. Exposure and color are key features of technically good photos. For exposure, the main characteristic that is evaluated is the brightness of the main subject through different use cases such as landscapes, portraits or still life. Other factors that are evaluated are contrast and dynamic range, for example the ability to render visual detail in both bright and dark areas of the image. Repeatability is also important because it demonstrates the camera's ability to provide the same view when taking multiple photos of the same scene. For color, the image quality attributes analyzed are skin tone rendering, white balance, color shading, and repeatability. For color rendering and skin tone, we penalize unnatural colors but respect the manufacturer's choice of color signature. Tests focus on focus accuracy, focus repeatability, shooting time delay, and depth of field. Shooting delay is the difference between the time the user presses the capture button and the time the photo is actually captured. This includes focusing speed and the device's ability to capture images at the right time, which is called no shutter lag capability. Even if a shallow depth of field can be pleasing for a portrait of a single subject or a close-up, it can also be problematic in some specific circumstances such as group photos. Both positions are tested. Focus accuracy is also evaluated in all real-life images captured, from infinity to close-up subjects and in low light to outdoor conditions. Texture tests analyze the level of detail and texture of subjects in images captured in the lab as well as in real-life scenarios. For landscape shots, Special attention is paid to the level of detail in the bright and dark areas of the image. Objective measurements are performed on histogram images captured in different illumination conditions from 1 to 1000 lux and different types of dynamic range conditions. The charts used are the Special Excimarc (DMC) chart and the Dead Leaves chart. Noise tests analyze different noise attributes such as intensity, color, granularity, and structure in real-world images as well as chart images captured in the laboratory. For natural images, special attention is paid to noise on faces and landscapes, but also on dark areas and high dynamic range conditions. Noise on moving objects in natural images is also evaluated. Objective measurements are made on chart images captured at different conditions from 1 to 1000 lux and different types of dynamic range conditions. The scheme used is the dead leaf chart and a standardized measurement such as visible noise derived from ISO 15739. The effects assessment looks at lens vignetting, chromatic aberrations, geometric distortions, edge ringing, halos, ghosting, quantization and unexpected hue shifts, among other types of possible unnatural effects on images. The more severe and more frequent the effects are, the greater the points deduction on the score. The main effects observed and corresponding loss of points are listed below. Preview tests analyze image quality in the camera app's preview of an image, paying particular attention to the difference between capture and preview, especially regarding dynamic range and bokeh effect application. Smoothness of exposure, color and focus adjustment are also evaluated when zoomed from the minimum to maximum available zoom factor. Preview frame rate is measured using the global LED timer. Excimarc engineers capture and evaluate more than 400 test images in controlled laboratory environments and in outdoor, indoor and low-light landscape scenes, using default camera settings and dial zooming at various zoom factors from ultra-wide to ultra-long range zooms. Evaluation is performed by visual inspection of images against a reference of natural scenes, and by making objective measurements of histogram images taken in the laboratory under varying conditions from 20 to 1000 lux and color temperatures from 2300 K to 6500 K. All image quality attributes are evaluated at focal lengths from approximately 40 mm to 300 mm, with particular attention paid to texture and detail. The result is obtained from a number of objective measurements in the laboratory and perceptual analysis of real images. Excimarc engineers capture and evaluate more than 2.5 hours of video in controlled laboratory environments and in low-light landscape scenes, both indoors and outdoors, using default camera settings. The evaluation consists of visually examining naturalistic videos captured in various conditions and running objective measurements on videos of histograms recorded in the laboratory under various conditions from 1 to 1000 plus lux and color temperatures from 2300 K to 6500 K. Exposure tests evaluate the brightness of the main subject and dynamic range. For example, the ability to render visible detail in both bright and dark areas of the image. Exposure stability and temporal adaptation are also analyzed. Color image quality analysis addresses color rendition, skin tone rendition, white balance, color shading, white balance stability and its adaptation to changing light. Noise tests analyze different noise attributes such as density, color, granularity, structure, and temporal aspects in real-world video recordings as well as videos of histograms captured in the laboratory. Natural videos are evaluated visually, with special attention paid to noise in dark areas and high dynamic range conditions. Objective measurements are made on video charts recorded at various conditions from 1 to 1000 lux. The chart used is the Excimarc Visual Noise Chart. At the end of the video, I thank you for watching and I hope you liked it, and see you in a new video.